Welcome, data enthusiasts. I am Joseph from Zuma, and this is our podcast, Data for Good. Here at Zuma, we are recruiters for senior data, insights, and analytics professionals, connecting you with Berlin's most influential and innovative companies. And today, we are joined by Marko Kolarek. He is head of data at Visual Asset Management, or VAAAM, essentially a platform solution provider to monitor and protect personal and professional IP copyrights here in Berlin and globally. I understand you manage data science, analytics, and engineering there. Is that right, Marko?
Yes, that's correct.
Cool. Excellent. How's it going with you today?
Yeah, I'm doing fine. Thank you. Yeah.
Excellent. And thank you very much for coming on the podcast as well. I look forward to getting into it today.
Sure.
Super. And right to it. Today's topic, I understand it is one of passion for you and certainly of interest in your commercial as well as personal domain. We'll be looking at the middle ground between data science and engineering, the research engineer.
Exactly, yeah.
Super. Well, just before we get into that, I would like to know, as we do with all our guests, about your first introduction and your first connection with data. Where did it start and what made you connect with it?
Sure. So I started working in the data area, let's say 7 years ago, 2015, when I joined Zalando. And specifically, I joined the A/B testing team at Zalando, right? So this team is responsible for building an A/B testing platform internally that's used internally by other teams to run hypothesis testing, run A/B testing, right? To evaluate whether a potential new feature is better than the existing status or not, according to some KPIs. And initially, when I joined the team, I was officially a backend developer, so helping with the first iteration of the service, right? Building up the services. But as time went on and different requirements came along, I pivoted more into a officially kind of a data science position, but then in the end determined as a research engineer position. And my role was basically to improve the analysis part of the testing, right? So of the hypothesis tests that were being run. As a part of that, I also collaborated on an open source library, a library that we open sourced for Python called XPAN, which is short for experiment analysis. And but why I wasn't strictly a data scientist, let's say in the regular sense, is that I wasn't responsible only for the research part, right? For let's say for researching advanced statistical methods, etc. But my responsibility also was to implement this in a production setting, right? This is where the engineering part comes along. At Zalando at that time, I'm not sure if they do it still, maybe they do. They had a framework where they differentiated between a, let's say, data engineer, a research engineer, and I believe that it was called a research scientist, which would be someone who is really, really deep into research, right? They also have a department that's really doing, you can imagine it like as Microsoft research, right? So a department that's researching all kinds of different topics without necessarily having a production goal in mind or a financial goal in mind, right? Just doing research in general and then seeing what can be actually then used afterwards. But yeah, that was my first step into this direction.
Brilliant. So you really do know about today's topic intimately. Yeah.
Yes, I would say yes.
Yeah, you've very much lived and breathed it, I should say. Yeah, and I really like that already we're starting to see that the connection between the engineering side and the data science side, being the experimental research and of course the pipeline building, deployment, that kind of those kind of tasks. But why don't you give your explanation? What is a research engineer?
Mm-hmm. Sure. So maybe another way to put it is someone who has an end-to-end responsibility for a data product, or maybe data science product or machine learning product, or anything in that area, where you would traditionally split the responsibility between a data scientist who does all the data science work, so building a prototype, basically, right? A prototype model or etc. And a data engineer who then has to picks this up, and actually brings it into production, right? So ensures that all the software engineering best practices are being taken care of, that the code can actually scale, etc., right? And as a research engineer, how can you actually pull this off, right? Because it's not. There's a reason why it's split into two roles initially. A data scientist has a lot of time and resources to actually go deep into a topic and be able to produce some kind of machine learning model, for example, right? Or some advanced statistical tool or whatever. And they don't have necessarily the time or the resources to worry about software best practices, putting this into production, how it's going to actually scale, etc., etc. And how you can actually then do this in the end is that a research engineer has end-to-end responsibility, yes, but only for a smaller part of an overall product, for example, right? Not, let's say, not a full-blown recommendation system for an e-commerce platform, right? That would be a very large chunk of work, but maybe a subset of it, right? Maybe let's take that as an example. Maybe a part of the feature engineering that's necessary for the recommendation platform, right? So this person, this single role, then is responsible to research different kinds of feature engineering that would fit for a recommendation problem. Of course, they collaborate with other team members as well on the overall product. But they are responsible for the feature engineering, for figuring out how to do, I don't know, one-hot encoding or whatever was necessary for this problem. But they can then actually also do it with software best practices in mind and launch it in production, and it can scale, right? They know they're also trained or have experience in other parts of this. I think this is a bit rare, especially because at least that was the state a couple of years ago. I think it's still happening. A couple of years ago, data science was really booming as an area, right? Everybody needed a data scientist, and but the hiring requirements for data scientists were not as well defined, I think, especially because it was so new, right? So I've worked with data scientists in different kinds of companies, right? E-commerce, transportation, etc., that weren't in any particular way specialized in these industries, right? Molecular biologists, geologists, etc., PhD, right? They have a PhD in this area, which basically, I'm assuming, to the employer guarantees that this person can really go in deep into the topic that's quite advanced and knows advanced statistics, maybe has used machine learning before, etc., right? But exactly because of their background, there is no guarantee that they know software engineering best practices, right? Maybe they've had a boot camp, they've done something more basic, right, on that side. And of course, they can produce a nice prototype, a good prototype that works on some kind of smaller data set, which is completely fine, right? And then when whoever is higher up okays that, then it goes into production. But this is where then the skill set is lacking, of course, on the data science side, because there's no reason for them to know this part, right? They've delivered the model, that's it. So that's traditionally how it looked. But nowadays, I think that data science and the general area of data is much more mature. And a lot of companies realized that they need data engineers to actually put machine learning models into production, or to actually scale what all the data science offerings that they have. And then ultimately, as an evolution to that, I see the research engineer happening more often, right? Because it's even more, it just combines all of the necessary skills, and it's easier for an employer, right, to have a person who can then be responsible end to end. It's very comparable, I think, to a full stack developer in a regular, let's say, regular web development sense, where you have a single person who can do both front end and back end development. I see this the same thing for the research engineer, right? This is a person who can do the front end, let's say, which is maybe the, let's say, the showing results, right?
Mm-hmm.
But also the back end, where everything needs to scale properly, quality is kept in mind, etc.
Okay, now I understand. But it sounds like there's only certain circumstances where this research engineer would be worthwhile or valuable. For example, environments that separate those different parts of delivery. You mentioned that this person would only cover end-to-end a small part of a solution or a subset of a solution. How about for organizations that don't separate their environments in such a way? Would this research engineer still be valuable to the team, given the breadth of tasks and responsibilities that they hold?
That's a good question, and I would say that really depends, right? You've hit it. You've hit the point correctly. It's about organization, right? How a company organizes their teams, specifically the data team. I would argue, right? I would say that in a modern organization, a research engineer has their place, definitely, especially for if you have a larger organization split into multiple different product teams, let's say. What I've seen happening is an embedded data engineer, so an embedded data person. Basically, there was a data team, there was a large data team that was responsible for, let's say, spinning up a data platform that can be used by other teams.
Mm-hmm.
But after a certain point, most of the tasks concerning the data team are what we call firefighting tasks, where upstream data producers are suddenly producing data that's of low quality or doesn't fit for whatever the needs are of the users of the data platform. Why this is happening is because often is that these teams, the upstream data producers, don't even know that they're producing bad data. They don't know that this data is being used for some other purpose, right? So this is why the term of an embedded data engineer or data person came along, where you would then split the data team into its individual members, or leave a core data team and then but extract some members out of the team and send them to these teams specifically to work with them closely, to understand better the product, and also to guide them when they generate the data, that there's certain data qualities in place, etc., right? And this is where I think the research engineer could also fit very nicely, because the research engineer, the position by its nature, needs to understand the product a bit better. It can't be completely agnostic about the product, right? While, let's say, most data engineers that are building a data platform, they don't need to know, or don't have the capacity, of course, to understand the whole company, all of the products and all of their requirements, data generation capabilities, etc., right? But if you, as a research engineer, join a specific team like that, then yes, it's a single product, it's easier for you to understand, and you already know what needs to be sent further down the line to the data platform. Also, while you're in the team, you can think about data science use cases that are useful for the platform, for the product specifically, right? So I think definitely in larger organizations, there's a place for a research engineer as well. Really depends on the organization.
Yeah, there's a challenge that comes up again and again, and that's particularly on the data science side, where data scientists are, let's just say there's a great demand for them to come with the commercial skills and not just the product skills or how they understand the product. With a really focused research engineer that's dedicated to that product and that even that subset, how are they able to grasp those? Or is there a disconnect between the whole commercial outcomes, the ultimate commercial outcomes, and what they do in this highly granular position?
Good point. Good point. Well, I would I wouldn't put any more pressure on the research engineer.
It
I think
sounds
this is
like,
already
yeah.
enough. Yeah, I think this is already a lot of pressure. So yeah, I think that I mean, if let's say we have a product team, right? And if the team is really focused on on certain goals, right? I would at least I would expect that the team also knows their ultimate financial goals as well. They should have some KPIs in place to track that as well, right?
Mm.
And then as a research engineer, as a part of this team, if you're also then aware of the ultimately the KPIs that are being tracked to measure the performance of the team, you can work then alongside these KPIs, right, towards the same goal. But yeah, I wouldn't put that much pressure on the research engineer by themselves, right? So this is a team effort, right? The team needs to also know which direction they're going in and why.
Understood. With the team, okay, so I think about why would a data professional want to become a data research engineer? What makes that position so attractive, do you think, rather than an end-to-end data scientist or an end-to-end data engineer? You know, those different mindsets that are involved.
No, sure. I mean, what's good about this, I think, is that you make yourself more attractive potentially to employers, right? If this is what this is your goal, right? You have just to have more broader skill set, right? So and personally for me, what's nice about it is that I have this maybe negative personality trait where I like to have always at least two things that I work at, right? So just for me to enable a context switch, right? So that I can take a break from one thing and then focus on the other, right?
I like that thinking.
Yes, yeah, exactly. And I think that as a research engineer, you by default, you have this, right? You have the research part, but you also have the engineering part. So you can always let's say, take a break from one focus and then focus on the other. While as a pure data engineer or pure data scientist, you can have different projects you work on, right? Of course, but ultimately they're gonna be in the realm of data science or in the realm of data engineering. But this is my personal personal take on it. So depends how it fits to someone, right?
And thinking, great. Well, thank you for that. I understand a little bit about your thinking now, and probably thinking of those in the kind of logical mindsets as well. If we now look at the data team leader, under what circumstances would they want to have a research engineer in the team? And would that research engineer replace any of the positions in the team, such as a data engineer or a data analyst or a data scientist?
So I think it's a research engineer. I think is beneficial in situations where you're initially developing a product, right? I think you can really draw parallels between a research engineer and a full stack developer, right? If you're an early stage startup, you're most likely not gonna hire a specific front end developer and a specific back end developer. You're gonna want a full stack developer. You're gonna want one person because you're really early stage, right? That can do everything for you. And I think in a larger organization, the same could apply, right? If you're just starting out with a product, you are definitely it's gonna be easier for you if you just have easier to iterate, easier to generate new products, just iterate more quickly on development. If you have all of this in one person, but then again, if the product itself grows larger, then it makes sense to specialize, right? It makes sense to have a specialist data a person that's only focused on data science, a person that's only focused on data engineering. But we're talking about larger, more established, mature products in that sense, right? So that I think that as a data leader, I think there's places for both in larger organizations. So, or all three of them, let's say scientists and engineers and research engineers. Depends on the use case, but yeah.
Okay, interesting. Where do you spend more of your time? Is it on the research as a data scientist might, or is it on the engineering and deployment, or is it completely equal?
Maybe I can speak better to the time when I was officially a research engineer at Zalando, right? Specifically, and I would say it was really close to half, right? Really more or less like, but that's maybe also my character trait that I liked it like that, like to split my work like that. But what was nice in that context was that I really was responsible for a smaller chunk, right? Smaller chunk of a larger product. We've managed to cut it up into smaller pieces like that were more or less independent, right? That allowed me then to really focus on the research and then focus on the deployment of that smaller subset of a larger product, right? So I think that, like in general in software engineering, I think that the concept of decoupling is good, right? Do one thing and do it really well. So it's just in general that this is what I think the general direction in the data area is. It should be that we pick up as many learnings as we can from software engineering, right? So because it's an established practice already, and software engineers most of the time know what they're doing, right? So
do you mean on the delivery of software, so the processes, or do you mean?
Yes, exactly.
Okay.
Yes, exactly.
Okay. So what should we keep with us, to take into best practice then from the software development lifecycle?
Well, exactly. To maybe first to treat it as a software development lifecycle, right? To have releases, to have proper testing, quality, keeping in general best practices in mind, right? It's a large list of what can be done, and I'm seeing this happen, right? With all kinds of different, like for example DBT. Let's look at DBT as a tool, right? DBT is basically is facilitating this, right? Is taking a more software engineering approach to data querying, to data quality, to ETL pipelines, because it ensures versioning, it ensures all kinds of different things that are important in software engineering and that are existing in software engineering for good reasons, right? So instead of let's say DBT to, I don't know, having a bunch of SQL scripts that nobody knows what they exactly do, have no comments, or cannot be really properly versioned, etc., right? But it's all in somebody's head. You know, the data scientist that's been there for 5 years, he knows what's happening. But yeah, exactly. So this is what I think I'm seeing is happening, and I would encourage all organizations to go in the same direction. It really makes sense to invest in this.
Right. Wow. Okay. So not just looking at organizations, but looking at data professionals, I'm thinking about if a data scientist or a data engineer should want to transition into this position. And with that, what would you suggest are the most critical tasks of a research engineer?
So which are the most critical tasks?
And therefore, in their transitioning, what kind of tasks should they be trying to take on more and more of to best prepare them for that research engineer position?
Sure. Well, there's two ways, right? Let's group it like that, from a data scientist into a research engineer, and from a data engineer to a research engineer. Let's take these two directions. I would say, like I've already mentioned, for a data scientist, learning more about software best practices, clean code, how to deploy into production, about scaling in general, right? Learning about distributed systems. That's a common task, common challenge that comes around with any kind of data science product. These are really important areas to look into. And yeah, how to exactly do it. I'm a bit biased in this regard because I'm a trained software engineer, right? So I can't maybe comment completely on how to do this, but there's so many resources out there. It's just that it's necessary to think about data engineering as software engineering. Have that mindset, and I think it's easier to find resources, easier to move in this direction.
Mm-hmm.
For
How
a
about
data
that?
engineer, sorry.
I mean, not just because of the title, but because of the importance of research. When I think of data engineers and even software engineers, I don't think of the research component so much.
Of course, exactly, because there usually is none, right? I mean, in the traditional sense. Let's say a generic task for a data scientist is they need to build some kind of new machine learning model. They look up the latest scientific articles about that, and then they try to implement whatever was in the scientific article, right? So for a data engineer, I would say a nice start out with this would be to try to read more scientific articles, get into that mindset, because you need to be in a certain mindset to be able to, at least for me, to able to consume information in that sense, in that form, right? And a good initial step, but I think a lot of data engineers do this honestly, is data analysis. Might sound boring, but it is very important for both roles, I think, to be good at basic data analyses, right? To know how to query your data, what to think of when you query the data, etc., etc. How, like, if someone gives you a KPI, that you're able to construct this KPI, etc. Right? So that would kind of be the first steps, I think, in that direction for a data engineer. Because like in data engineering, like software engineering, has a lot of solved problems, let's call them like that, right? You need to, I don't know, build some kind of data pipeline or something. You can use an existing tool, right? You can use DBT, you can use Spark, whatever, right? Someone already solved it. While data scientists are solving different challenges. They're trying to solve something that maybe isn't exactly solved yet, or is solved but not in a not in the way or form that they needed for their product, for their KPIs. That's, I think, the biggest difference in reasoning.
Okay. Are there any tools that are different that a research engineer would use that perhaps a data engineer or a data scientist wouldn't use? Or is it a merging of all of those tools as well as their skill sets?
Sure. Well, what I would say is that if you're a depends. I would say when I think about tool choice, I think more about the overall support that you have in the company as well at the moment, right? So let's say you're in a good place where you have a lot of support. There's an infrastructure team. Let's say there's a data team that's already providing some kind of data platform. Then your tool choice should just be guided to fit with that, right? So if already somebody's running a Elastic MapReduce cluster, then you're just going to use tooling that's built on top of that. Let's say like Spark, for example, or Apache Beam, or I'm talking specifically about AWS maybe in this sense, but just as an example, right? Or if somebody's already using Databricks, then you also use Databricks, right? You can write notebooks, you can do all kinds of stuff with Databricks as well. So it's more end to end, let's say. But in general, I think that notebooks like Jupyter notebooks or any kind of notebooking platform are very much end-to-end, but not completely, right? So it depends. Some of them you can immediately even deploy to production, but with some of them there's still some extra work needed, right? And of course, more a general tooling question, I mean, very general tooling question, programming languages, right? I think Python still wins. So Python still is the most, like, if you're just starting out, it's best you just learn Python and stick with it for a while before trying to invent something else or use something else. It's possible to do both data engineering and data science in different languages. Scala comes to mind, especially for data engineering, but I'm not sure it's worth it immediately when just jumping into this. I would if I could start, if were starting over, I would definitely start with Python.
Okay, brilliant. I'm conscious of time.
Mm-hmm.
At this stage, we usually move on to the advice question, but I think throughout this podcast, you've given us lots of advice and tips for people who might consider a move into this position, tasks and tools, the advantages, why to get into this area. So my final question for you would be the future.
Mm-hmm.
What does it look like for businesses in terms of research engineering? Is this, do you envision this to be a growing area?
Mm-hmm.
Period.
Well, I do, especially as companies become more mature in their data capabilities, right? Like I said, I think there is a place for a research engineer in every company of a certain size, right? I mean, even for startups, maybe even especially for startups, right? So I see this happening definitely, and also maybe on a more bleak note, given the current financial situation and financial, let's say, crisis that I think I can say crisis that we're going through with so many layoffs, etc. I think it's a good idea to broaden your skill set because it makes you more valuable, right, to a company. So if you're a data engineer, you're thinking about how you can increase your value for a company, I would suggest that that's a good idea. Same for a data scientist. Whilst doing a more, let's say, bigger jump to, I don't know, to being a front-end developer or something that's not, sounds maybe like in the similar area, might not bring you the same amount of value. Depends, but just as a general observation.
Interesting. Thanks for that overview. And great to hear your opinions as well. I think this area is a bit of a challenge for data scientists and data engineers to wrap their head around, especially given that those two positions are already quite broad and very, very challenging. And you know, they demand different mindsets and different brain functions. So yeah, you have clearly come from a strong position to develop those skills in research engineering. Marko, thanks very much for today. I suggest if people have questions about the research engineer, then I'd like to encourage them to get in touch with you.
Of course.
And I think LinkedIn at the moment is usually the best way of doing so. So yeah, once again, thanks very much for that. And I'll look forward to exploring a new topic with you sometime very soon.
Sure. Thank you.